Alrighty, it is a handwritten worksheet, which means one of two things. Either I ran out of worksheets to pull from the server and I had to come up with something to keep everyone entertained, or it is the review before the assessment. Luckily for you, it is the review before the assessment. But don't worry, I'll come up with other things to keep everybody entertained later. So yeah, again, we're going to start out with the assessment review. There's a little bit of a mixture of vocabulary plus some applications of some new ideas. There we go, just moving everything forward here. Plus some applications of some new ideas. So yeah, let's go ahead and get some reviewing done. Identify some polynomial features. This is pretty similar to our previous review, where we have to identify the degree, leading coefficient, constant term, and what the type is. So thankfully, everything's written in the standard form, so we don't have to work too hard with this. So for the first one, the degree. The degree, of course, is the highest exponent that is present. And for this one, it is going to be 2. That is the highest exponent present. The leading coefficient is going to be the coefficient that is attached to the to the number with the highest the to the variable with the highest degree on it. The 4. It's the 4. It's the 4. It's where it's the 4 is attached to this thing, so it's the 4. And the constant term. The constant term is the term that does not have any variable attached to it. So in this case, 3. Oh, wait a second. It is -3. I forgot about that. It is -3. And then finally, we have a type. Is it a monomial, binomial, or trinomial? It is going to be a trinomial. Alrighty. Next we have next we have another polynomial that we're looking at. We'll start with the degree because that's where the worksheet says we need to start with. The degree, again, these are written in the standard form, so we just need to go all the way to the far left, and we can see that the degree is going to be 4, because that is the highest that is the highest exponent of the entire polynomial. The leading coefficient of this is going to be -1. The constant term here, the constant term here is going to be 5. And the type is going to be, and the type, again, it depends on how many elements are in the polynomial, including the constant, but it's 1, 2, 3, 4. Okay, so so trinomial means that you got 1, 2, 3 things. All right, but if you have anything with 4 or above, what you have is what's called a polynomial with, and then you have to list how many terms you have. So in this case, we have a polynomial for, there we go. So we have a polynomial with 4 terms. If we had, well, I mean, obviously, if we had 5 terms or 6 terms, we would just change the number and move on. If you want to, okay, I'll just put it this way: if you want to be cute and name all of these polynomials, you're technically not wrong. But I'm going to try to ask you for the most complete and accurate definition, especially because this is we're getting ready for the second assessment, and you probably should be pretty well versed with the vocabulary by now. Or at the very least, you should have this. Hopefully, this isn't the second time you studied it, but who knows? All right, moving on to the next one. So the degree for this one is just going to be 1. Which does beg the question, if you just had a constant, what would the degree of the polynomial be? I would say 0. Also, you don't have a polynomial if you just have a constant. Because there would be no leading coefficient, there would be no type, there's no type for it. You just have a number. It wouldn't be a polynomial. I mean, I guess you could call it a polynomial of degree 0, but there are easier ways to describe it, like calling it a number. Anyway, leading coefficient is the number that's attached to the variable that has the highest degree, so that would be 6. Leading coefficient. Wait, no. The constant term, we do not have one, so that is equal to 0. And then the type, we have a monomial, or a polynomial containing exactly one term. All right, next one. We have x to the third plus x to the squared plus x plus 1. Alrighty. For the degree, with this one, the degree is going to equal 3. The leading coefficient, there doesn't seem to be one, but so that just means that the leading coefficient is 1. The constant, also 1. And the type, 1, 2, 3, 4 polynomial. With 4 terms. Alrighty, and that does it for part A of our review. So moving on to part B, rewrite in the standard form. Again, remember the standard form is you have the largest exponent on the left, and then you work your way to the right in descending order. So 3, then 2, then 1, etc. In this case, I've got x to the third, looks like it's the highest one, and then 2x, and then the constant, or just the number, it's always going to be on the far right. So that's always going to be a gimme. So in this case, I've got negative x to the third plus 2x plus 4. And there we go. Boom goes the dynamite. This one, all right, I've got four elements in it, 4 terms in it. The highest one looks like it's going to be x to the fourth, so that gives me 3x to the fourth. The next highest looks like it's going to be x to the x squared, so that's going to be minus 2x squared. The third one is going to be minus x, and then of course the constant is always going to be on the right. The constant is always going to be on the right. Yeah, even if there's any doubt about it, if you have to choose between minus x or plus 1, the constant is always on the right. It is always going to be at the very end of your polynomial if you're writing it in standard form. Alrighty, the vocabulary will continue. The vocabulary review will continue. Label each as a monomial, binomial, trinomial, or polynomial. Just with a quick look, it looks like we're only going to have one polynomial. But anyway, let's see. This one only has 2 terms, so it is going to be a binomial. This one has 1, 2, 3, 4 terms, so it is going to be a polynomial with 4 terms. Remember, if you're going to label anything as a polynomial, you have to list how many terms it has attached to it. Let's see. Next one is going to be a monomial. And the last one, 1, 2, 3, trinomial. Alrighty. Now we get to the meat and potatoes of what we've been doing most of the week. Again, most of my assessment reviews are going to be concept reviews and vocabulary reviews because the assessment goes over them, but it's math class, not vocabulary class. But anyway, add polynomials. Let's see, I've got, okay, so these 2 terms inside the parentheses are written in standard form, which is solid. I've got 2x squared plus x squared, so that's going to give me 3x squared. Don't have to worry about those. I got 3x minus x, so that gives me plus 2x. And then minus 5 plus 4, minus 1. And there's the first one. All right. For this next one, it looks like I got to the third, to the 1, and then the constant. All right. And again, everything's written in standard form, so I can just go left to right in the parentheses. it's very easy to add these together. So got negative x to the third plus 3x to the third, so that's 2x to the third. 2x minus 4x, so that's minus 2x. And then minus 6x plus 1 is minus 6x. Minus 6 plus 1 is going to be minus 5. And there we go. That's that final answer. Here, I'll pull this up a little bit more. There we go. That's that final answer. Again, the questions are written in standard form, so it's really just a left to right. It's not meant to be a challenge. It's meant to be a concept check to make sure that we're all on the same page as far as what's expected with adding polynomials. Alrighty. Next, we've got, alrighty, multiply polynomials, special cases. Oh, that's right. Simplify each product. Well, I've got, so this is going to be a, perfect square. So this one's going to be x squared minus 10x plus 25. Because the form, if you remember, for perfect squares is x plus minus a squared, and if it's plus, it's going to be x squared plus 2ax plus a squared. If it's minus, there we go. I'll do everything on camera now. You are. If it's minus, it's going to be x squared minus 2ax plus a squared. Yeah, and then of course the perfect square is, let's see, where is that? All right, and then the perfect square is x minus a, x plus a, and that equals x squared minus a squared every time. All right, so yeah, we'll just keep going forward. So I've got x plus 3 squared. So I've got x plus 3 squared. All right, that's x squared plus 6x plus 9. All right, can't argue with simplicity. X minus 4, x plus 4. All right, that will give me x squared minus 16. There's that one. Here's that one. X squared minus 16. Okay. Now this one, I like this one a little bit more. This one requires a little bit more thought because if you remember when we went over this in the worksheet, I tried to blast through it really quickly and it kind of caught me up and it kind of stumbled me. You have to remember what the format is, and even though it is a shortcut, it's a shortcut to a shortcut. So if you want to do like FOIL, that's a shortcut for multiplying everything through. Multiplying through polynomials is a relatively dull process. FOIL makes it fast. These forms make it faster. So you're already taking a shortcut to a shortcut and saving all kinds of time. So there's no reason why you can't just like take a breath and make sure that you're doing everything correctly. So 2x minus 1 squared. So that's going to give me 4x squared. And it's going to be minus 2 times a, which is going to be negative 1. I've already got that. Times x, which is going to be 2. So that's 4x plus 1. Okay. 2 times 4x plus 1. Yeah, I think that's right. I think I'm in good shape with that. How can I be sure? How can I know that I am 100% correct with this because I've had issues with it in the past? Well, there's only one way to be sure. Oh, that's right. It's happening. It's happening on the review right now. 2x minus 1, 2x minus 1, 4x squared minus 2x minus 2x, 1, 4x squared minus 4x plus 1. There we go. All right, we're in good shape. I got it right. I took my time. I relied on the rule. I took my time, relied on the rule, got the right answer. All right. Let's see. Multiply binomial and polynomial, simplify each product. Um, hmm. You know what? I think, let's see, do I want to do this with, well, I've got three that I have to do. So I think what I'm going to do, I'm going to do, um, so yeah, that's what I'm going to do. I'm going to do box, then I'm going to do dist, then I'm going to wrap things up with a box again. So I am probably going to need a scratch sheet of paper, which is good because I I originally wrote all of these reviews out with the intention that folks turn these in with scrap sheets of paper. So they keep the review, they turn in scrap sheets of paper, and they have the review with them so that they can look at it and say, hey, what did I forget? What did I remember? Things like that. Um, they can and just kind of study it on their own time. But the fact is that most people don't study. No, I'm just kidding. The truth is that the answers themselves you can actually fit on the paper. So it's and they don't study. So we're going to get started here. So I got problem number 17, and I'm just going to draw everything out here, and I'll copy the answers over once I'm done. So let's see, I've got draw that there. And I know it's thrilling watching me not draw something on camera, but here we go. So, all right, this is the first box for number 17. I've got x plus 2, and then this is x squared minus x plus 3. All righty. I'll just put this off to the side. So, x squared times x to the third, x times negative x, which is negative x squared, then x times 3, which is 3x. Then x squared times 2 gives me 2x squared. 2 times negative x gives me negative 2x. Then 2 times 3 is 6. All right, now our products combined, and gives me x to the third plus x squared, because 2 minus 1. Negative 2x plus 3x, so that's plus x plus 6. All righty. So we'll go over here and write that out. Because again, like I mentioned on one of the other videos, while I'm recording these, even though I got the answers and I wrote the answers down and I recorded myself getting the answers for the video, that's all well and good, but part of the other reason that I'm doing this is in front of you, I'm generating the answer key so that when you turn in the homework, you can see what I'm grading and what the rubric is and what the standards are for the answer key. Also, you can see how generous I am when people catch mistakes and and fix them. Yeah, there's absolutely no reason to not there's absolutely no reason to be embarrassed about mistakes. Otherwise, I would have done a lot more editing, especially with some of the earlier videos. All right, let's see. So for number 18, I'm going to do this the old distribution way. So for number 18, I've got 2x minus 3 times x squared plus 4x minus 1. So that's going to be 2x times x squared plus 4x minus 1. And then that's going to be minus 3 times x squared. I don't know why I'm looking at the other paper because I've got the thing right here. Okay. Now, normally I try to restrict things in order to save time, but I'm really going to go deep into the distribution on this one because I've got space. And now that I've got space, I can actually write things out a little bit more. So what that means is this is going to be 2x times x squared plus 2x times 4x minus 2x times 1. And so that's what, and anyway, I'll finish writing this out. Minus 3 times x squared, 3 times x squared So what I'm going to do is I'm going to multiply everything by minus 3, but I'm going to add them together. So this way I don't have to mess around with signs later on. Minus 3 times x squared plus minus 3 times 4x plus minus 3 times minus 1. Okay, so whenever we're doing distributions, and I mean, I know it's a lot to look at, but what I'm doing is I'm taking every single element, and I'm taking this and I'm multiplying it into every single element in the parentheses. And this time I actually have the space and the ability to write it out exactly what it is I used to, like earlier on with some of the other problems. I was just saying, all right, 2x times x squared, 2x times 4x. I was just saying it. Now I actually have the room, I can draw it out and show you exactly what it is I'm doing. And then it looks big, but that's just because, again, I'm drawing it out to illustrate an idea. And then we'll just get everything nice and small again. All right, so I've got 2x times x squared, so that's going to give me 2x to the third. Then I've got 2x times 4x, that's going to give me 8x squared. Minus, and then I've got 2x times 1, plus, and then I've got negative 3 times x squared, so that's going to be minus 3x squared. And then this is going to be minus negative 3 times 4x is going to be 12x, so minus 12x. And then plus negative 3 times negative 1, which is going to be plus 3. And that's that's the next distributive step. At this point, we'll start combining like terms as we ever do. So I don't know what I was thinking with that. So we have 2x to the third plus, because we don't have any other x to the third options. So I'm looking at let's see what the next one is. So I've got squared. I've got 8x squared minus 3x squared, so that's plus 5x squared. Let's those out of the way. I've got minus 2 minus 12x, so that's minus 14x. And then 3 is on their own, so that's plus 3. All right. So that means that the final answer for this one is 2x to the third plus 5x squared minus 14x plus 3. Okay, which brings us to the last box problem in the review. So, alrighty. So while you're looking at the box problem in the review, there were some issues with the typing and the nomenclature on this one. Again, I was working with a problem generator, and I apparently missed this when I was trying to clean up some of the pictures, but this is supposed to be an exponent, this is supposed to be an exponent, and then this is literally just x plus 2. But anyway, but I've got 1, 2, 3, 4, but that's not going to make it, it's not really going to make that big of a difference. If we can make a box work with 3 columns, we can make one work with 4. At least I hope we can. It's going to be really embarrassing if, it's going to be really embarrassing if everything falls apart and I go look online and it says, whatever you do, don't use 4 with a box. What are you, crazy? All right, so x minus 1, and then that gives me x to the third, x squared, negative x, 2. All right, so swap those out. Like I said, I went ahead and just created the box and put it right down there. So again, our normal, the biggest size that we've worked with so far has been up here, but we're moving down here. And normally, what we would do is we would stick with the distributive method, because with the distributive method, it doesn't matter how many terms are in the, it doesn't matter how many terms are in the parentheses. because the operation is basically the same. You're multiplying it through here, but now you're just using 4 terms instead of 3. So the safe operation is the distributive one because it works. It's just a little more time intensive. But honestly, I think the box method will work too. It's just, it's just the new kid on the block, or it turns out the old kid on the block, and I just didn't realize it. So, all right, moving across, I've got x times x to the third, which is x to the fourth. I'm going to invoke the trivial rule because, again, if I'm multiplying everything by x, then all I'm doing is increasing the degree by 1. So that means x to the third, negative x squared, 2x. And then I got to invoke it on this one too because all I'm doing is multiplying everything by -1, so I'm just switching the signs. Negative x third, negative x squared, x minus 2. All right. So, well, it didn't take nearly as long as I thought it was going to. So that leaves me with x to the fourth, x to the third minus x to the third. That's done. Minus 2x squared plus 3x minus 2. All righty. And so that will be our final answer for the review before assessment, before the second assessment. X to the fourth minus 2x squared plus 3x minus 2. Alrighty. So yeah, there we go. And coming up next is the second assessment. So yeah, off we go, off to the races.